during this tutorial, we're going to be, this hack week, everyone's going to be using Python for the most part. And Python is an object-oriented language, and we'll talk about what that means in just a second. But what I'm hoping that everyone will get from here, I feel awkward with my back. I can't stand in a way such that I'm not that I don't have my back to someone. So I'm hoping that through this tutorial, we can talk about how to best leverage this kind of coding paradigm and implement that in your Hack Week project design. So let's just do some brainstorming real quick. Let's quickly talk about what makes it easy to collaborate with others. And maybe I'll kind of partition this slide here and say, what makes it difficult? And so just shout it out. Like, you don't have to raise your hand. I don't do the teacher thing. What are some things that make collaboration easy or difficult? Misunderstanding each other's words. There are 2 S's in misunderstanding. Different backgrounds. Should mention, I'm a physicist. I can't spell by default. All right. Good communication. Having fun. I like that. Listening. I want to elaborate a little bit on this good communication thing, because I feel like that's a big one. So I would add on to this maybe like clear objectives. Anything else that we want to add?
Role clarity.
Role clarity, that's a good one. Okay, so I think we have a pretty good list over here. And what I want to try and argue with you is that if you can effectively implement an object-oriented structure in your code, not only can you have a lot of fun, which I don't know, some people would disagree with me, but we can set up our code in a way that addresses some of these things. So we need to be very deliberate with how we want the user to interact with our code, how we want other developers to interact with our code. And so let's jump into this object-oriented programming that I keep alluding to. So what is this? This is just a coding paradigm that allows us to modularize our code. So I'll start writing this down. So object-oriented programming. I feel like I can hear an echo of myself through the Zoom call. There we go. Okay. This modularizes, I'll use the American spelling, modularizes code into chunks effectively. Or formally in software development, we call these chunks objects. Okay. And an object is a data field that has some kind of attribute and behavior, or attributes plural. And we'll say which is a data field that has unique attributes and behaviors. Okay. So that's a lot to take in, but we'll break things down. And I should mention that everything in Python is an object. Python is an object-oriented language. If you're writing in Python, you can't avoid this. So let's take humans as an example, right? I mean, I don't mean to objectify anybody, but in terms of programming, we can define some kind of class of human that has behaviors and attributes. So here is my human. All right. And we'll denote this as a class. And attributes are things that humans have. So we'll make a list of has. And so, I don't know, things that we have. Everyone has a name. We might have, you know, a certain amount of energy based off of how much sleep or caffeine we've had. And I hope that humans have friends. So these are just some very basic qualities that I hope is universal across every human. And then there are things that we can do, right? So a human does. So these are our attributes. And these would be our behaviors. So we can walk or locomote in some way, right? Be it, you know, on our feet or in a chair, or we can move and get ourselves from point A to point B. Okay. We can also sleep. Maybe not if you're a grad student. And we can make friends. All right. So I've just drawn this very like conceptual map of what our programmatic human in the realm of our Python notebook is going to look like. So how do I take something high level like this and turn it into code? So this is where I'm going to flip over to the Jupyter notebook. Okay, and maybe I'll make this a little bit bigger. Is that an okay font size? There we go. All right. So let's go ahead and define this human class in our Python notebook. So I'm going to say class human. In Python, it's best practice when defining a new class to capitalize that variable, so or that title, right? And that's just so we can distinguish between what is our human framework versus when I actually create an instance of that object. So we need to initialize this. And so what I've done here, within Python, whenever we create a new type of object, we need to initialize it. And so this is one of those things that Python kind of does behind the scenes. And the syntax for that is denoted by these double underscores before and after. So anytime you see a function with the double underscores before or after, that means that it's like a keyword or a flag for Python to do some magic behind the scenes there. So when I create a new instance of a human, I need to refer to myself, I guess. And we're going to pass in the name of this person, right? So we bring a new person in, and we have to give them a name at the very least, right? That's unethical if we don't. So within here, I'm going to say that self.name is going to be the name that we pass in. Okay, so this name here refers to the name that the user provides. File chain was changed on disk since the last time it was opened, or said. I think we're okay. Yeah, so what I'm doing here with the self just means that I can have multiple instances of human, right? Like our little Python universe that we're creating can have multiple humans in it, and I just need to refer to that one particular instance of human. So I'm going to refer to self. I'm also going to say that we have some default energy level. And I'll just say that it's maxed out at like 10. And we can also have some friends. And initially, we might not have any friends, right? We need to go out into the world and meet people and make friends that way. Okay, so this is representing all of the things that our human has, right? So I said we have a name, energy level, and friends. I also want to, this would be more for the user. I'm going to define this string function. And so what this will do is anytime I call print, right? Actually, you know what? Let's we're going to just leave that out for a second. I'll make my point in about that later. Okay, so these attributes here are things that our human has, and now I'm going to define functions to represent what our human does. So we can move. All right. Again, I need to refer to myself. And we're going to move by some number or some distance. So we'll say that the distance by default will be 1 unit, whatever that is. Okay. But we're only going to move if we have the energy to do so, right? Like if you're tired and ready to just like fall asleep standing up, you're not going to move anywhere. So let's check if energy. If that's any less than the distance that we want to move, let's communicate to the user that this particular person doesn't have the energy to move that far. Oops. Otherwise, we'll move that distance, but also subtract that quantity from how much energy we have. Okay. So that will be how we move. We also said that humans can sleep. Again, I have to refer to myself. And when I sleep, I'm going to replenish my energy level. And we'll just set that back to 10. All right. The last thing that I said that a human can do is make friends. Again, I am the one making friends. And I also need to tell my program with whom I am becoming friends. So I can say self.friends, and we'll append this person to our list of friends. But this is a mutual process, right? Like I can't make friends with you if you're not friends with me. So I'm going to say that my friend I'm going to add myself to this other person's list of friends, right? So instead of this, so the first line says this instance of human, I'm going to append to that another instance of a human that I'm denoting as my friend. And likewise the reverse. So this time my friends list of friends, I'm going to append myself. Okay, so we'll go ahead and run that. And we'll define a few humans. We'll say that A is a new human with the name, I don't know, Alice. And oops. B will be Bruno. And C will be I don't know, Chantel. Okay, so I have created 3 humans in this world that I have. Okay, so now as a programmer, if I want to, receive some kind of information about what these humans look like, I can print that reference to that human. Okay, so here's the problem. When I print this new object that I've created, Python doesn't know how to handle that yet. Python doesn't know how to present this multifaceted human that I've created as a string. And so it's just going to spit back at me a memory address. But that's not very useful. So when I call this print function, now we're gonna go back to here. All right. Python behind the scenes is actually looking for the string representation of that object. And that's what we're doing with this. So just like init has this double underscore before and after, I'm now going to define what a string representation of this object that I've created looks like. And so I might define some kind of string and we'll say, hi, my name is, and then we'll pass in the name. My energy level is something else. Okay. This is another fun little Python quirk where if I take a string and I use these curly brackets with indices in it, I can add dot format to the end of that string and then pass in what I want to go in those things. So in the 0 index, I'm going to say this is self.name and self.energy. Okay, so let's run this again. I see the mistake that I made here. Okay, so I have defined this string, but I didn't actually give it back to Python. So I need to return the string that I just created. All right. There we go. All right. So now when I want to display some string representation of this human, I said, hi, my name is Alice and my energy level is 10. Awesome. So we can go on and interact with these people in a new way now. So I can say like a.move. and I want to move a distance of 3 units. And now we'll say like print A. All right, and Alice's energy level has now gone down to 7. So let's make some friends, right? So let's say that Alice make friends. Alice is going to make friends with Bruno and Chantel. Oops. I think I might have buggered something up here by running that cell, because I think now we're going to have Bruno as double friends. Maybe Bruno is Alice's best friend. So let's display. So let's say print Alice's friends. And we'll say for I in a dot friends. Let's just print their name. Okay, likewise, we'll do the same for Bruno, right? Because now Bruno should have Alice as a friend. And we'll add just a new line there, just so it's not writing over itself. All right. There we go. Okay, yeah, so by running that cell twice, I now added Bruno twice to Alice's list of friends, but that's okay. So Alice's friends are Bruno and Chantel, and Bruno has Alice as a friend. Cool. So this is our first little example, but humans are very multifaceted creatures, right? Like there are different types of humans. So let's create another example. And I will go back to my notebook. There we go. Okay, so there are different kinds of humans with different roles. And so we'll use a bakery as an example of this. And so I always like to start by drawing a picture. And so this is going to be my bakery. All right, and a bakery will have a baker. Okay, here's my baker. And they're going to wear a little chef's hat. Okay, I didn't go to art school for a reason, but here we are. So this is our baker. And bakers are humans. All right. Likewise, I will have customers. So here's this is the counter with my little cash register. And I have customers. So we will have customers. And customers are also humans. And for the sake of simplicity, this bakery only sells cookies and just one type of cookie. It's going to be this is going to be one of those like little hipster bakeries that specialize in one particular type of gluten-free, sugar-free, I don't know, some kind of cookie. Vegan, right? It's very niche, right? But they do this really well. These are the best vegan gluten-free cookies you've ever had. All right, so this is a picture of our bakery. And again, I want to start turning this into code, but there's a few steps that we have to do beforehand. So every image pictogram that I've just drawn here needs to be represented by our code in some way. So let's start with the bakery itself. All right, our bakery has a baker, which is a human, and cookies for sale. And we'll just represent however many cookies we have by an integer. Likewise, our baker in addition to all of the things that humans have, right? So our baker is going to have a name and friends and some energy level, but they're also going to make a commission, right? We need to pay people living wages. Okay. And they're also going to do some action that maybe not every human knows how to bake cookies, right? I'm a lousy baker, I'll tell you that much. And so there does, right? So has, these are all going to be attributes or that self dot whatever, and the does are going to be methods that we add. So these are the actions. So our baker is going to make cookies. And our baker will also sell the cookies. Okay, so I need to add another page because I'm running out of space. All right, the other thing that we've drawn is our customer. And our customer is going to have some amount of money with which to purchase these cookies. And after they've purchased those cookies, they will have cookies. And that will make everyone very happy. Okay, I think maybe just in a different color, we might say the customer will buy cookies. Oops, B-U-Y cookies. But I'm not going to code this in where the customer, in the customer class. This action is going to be taken care of by the baker. All right. And so this is kind of one of those things that's like open to interpretation. I'm going to choose to have it represent or be an action done by the baker. You can choose to implement it the other way. I think that's fine too. All righty. So now that I've come up with this list of things that I need to represent, right? So I need to make a class of bakery, I need to make a class of baker, and I need to make a class of customer. And then I need to implement all of these different qualities and behaviors within those classes. So we'll go back to our Python notebook. And let's go ahead and start with the bakery. And I always need to initialize it. And we'll give it some default number of cookies to start with. And each of those cookies is going to have some cost associated with them. So we'll say that self dot number of cookies is going to be given by whatever the user tells us. And the cost of each cookie is going to be whatever, again, the user specifies. Okay, I want some way of seeing what this instance of bakery looks like, and so we'll write that string function again. And I'll say that this time we're going to say this bakery has so many cookies for sale. Cookies for sale at, and that price. So self dot number of cookies and self dot, what do they call that? Cost. All right, and then I have to return that string. Cool, that is our bakery. We have created a bakery. Invalid syntax. What did I do? Sorry, what was that? Class is capitalized. Thank you. There we go. Okay. All right, let's our baker. And this time I'm going to add something special to this, right? Because remember, bakers are humans. And so I want my baker to have all of the qualities that the human class I've defined also has. So I'm going to tell Python that my baker is indeed a human. And so I'm going to initialize that. All right. And again, because a baker is a human, we have to give them a name. Okay, here's where things get interesting, right? I have already defined some kind of initialization for humans where I pass in a name and it's going to set their energy level and whatnot. So I can call on that by saying super, which is the super class. So that's the higher level class that I'm referring to, human in this case. And I'm going to pass in the name. Okay, and so what this is doing is it's calling this function over here where we give it the name and it'll set our baker's energy level and our friends. All right, but we said that a baker is also going to make a commission, right? So we can say that, we'll say that self.sales. And our baker hasn't made any sales yet. Okay. So the actions that we agreed on, right, we'll say that our baker will make cookies. And we have to connect our baker with the bakery. So that's going to be some instance of a bakery. And we'll give it a number of cookies that we're making. And we'll say that, so when our baker makes cookies, we're going to increase cookies. We're going to increase the number of cookies that our bakery has by whatever amount. Okay, so our baker can also sell cookies. And it's ourself that's doing the action. We are selling the cookies to a customer from the supply at our bakery. And there's a quantity of cookies that this customer wants to buy. So we need to check a few things. We need to make sure that our bakery has enough cookies to sell. So you can say that if the number of cookies the customer wants to buy is greater than what is available at the bakery, then let's print this bakery doesn't have enough cookies. And then we're just going to cut things off there. So I don't want to execute the rest of this function if that's the case. All right. The other thing that we have to check is if our customer has enough money to purchase those cookies. So we'll calculate a subtotal, and that's going to be the number of cookies times the cost. Bakery.cost. Okay, and then if our customer doesn't have enough money, then we also want to give a message saying the customer can't afford these cookies. And again, we'll just cut things, return. We'll just cut things off there. Okay, assuming that we have the number, enough cookies to sell and our customer has the funds to purchase them, then we will subtract the number of cookies bought. We'll subtract that number of cookies. Our baker is going to make some money. Our customer will lose some money. And they will gain cookies. All right. So those are all of the things that our baker will do. And now let's create our customer. And again, they are a human. So we will initialize we'll give them a name, just like before. Oops, I have to say self, right? Because this is that one particular instance. And I'll call the super function so I don't have to reinvent the wheel there. I have some amount of cash. Oh, I guess I should also tell myself how much money I have to spend. And initially, our customer does not have any cookies. All right. So we can also say, let's find a way to represent our human with a string. All right. So again, I'll say that my string is going to be the same as that of a regular human. So it'll be super. Okay. And on top of that, I'm going to add a space, and I have however many cookies. Okay, and then we'll return that string. All right, so I have created a bakery. I've created a baker for that bakery, and I have created a customer. So let's imagine this. See, programming is fun. Remember we had having fun makes programming easy. So let's invent this hypothetical world in which I am actually good at baking. So I'm going to be a baker, and my name is Romina. All right. So let's just remind ourselves, over here within our baker class, I didn't define a string function, but I'm still a human. So if I print, it's going to call that functionality from the human class. So that's the fun thing, right? So the technical term here is called inheritance. So because a baker is a human, it inherits all of the qualities and actions that humans have. So I can still move, I can still sleep, I can still do all of the things that humans do. But in this world, I can also make delicious cookies. So let's create a customer. And so let's say our customer is Kelsey. Shout out to Kelsey, who wasn't able to be here. Customer. And this is Kelsey. And her cookie budget is $10. All right. And so when I display Kelsey, right, it says, hi, my name is Kelsey, my energy level is 10, and I have 0 cookies. All right. So now I have to create a bakery. Anyone have a preferred bakery? Tallgrass, why not? I'll have to go there. I've never been. All right, so this is our bakery. Maybe they should sponsor me. All right, I have to tell my bakery how many cookies we're starting out with and at what cost we're selling them. So let's say our bakery has 20 cookies and they're going to be $1.25 each. All right, so there we go. This bakery has 20 cookies for sale at $1.25 each. Awesome. So now if I want to interact with this, right, I, as the baker, want to sell cookies to Kelsey, who wants to buy my delicious, gluten-free, vegan, ethically sourced ingredient cookies, right? This is a very niche bakery. I do one thing, but I do it very well. So I'm going to sell cookies to Kelsey from Tallgrass. And let's say Kelsey wants to buy 5 cookies. So let's see what Kelsey has to say now. And we'll make sure that things are working by looking into Kelsey's bank account. And we'll see what the bakery looks like now. Cool. So Kelsey is very happy. Her energy level is at 10 and she has 5 cookies now. She's very happy. Unfortunately, she blew, 75% of her budget on, on cookies. And so she only has $3.75 left. But my bakery has 15 cookies now for sale at $1.25 each. So we can continue playing with this, but I see that it's 9:30 and you are hungry for cookies and probably coffee. So I'll leave it there, but let's just quickly recap, right? So I want to go back to my notebook. And let's quickly talk about how we addressed these, things. So when I write effective object-oriented code, I want to communicate clearly what each of my functions are doing, what they need as an input and what they need as an output. And so what I haven't done, again, just for the sake of time, is good documentation. So as I'm writing my code, I want to communicate to whoever is interacting with it, what types of values I'm allowing. And that could be object types. So like if I'm, it doesn't make sense for my bakery to sell 3.5 cookies, right? Like that doesn't work well. But again, when I'm interacting between those different objects, right? Like when I'm selling cookies, I need to have a customer, right? So that's an agreed upon input. I need a customer and I need some integer representing the number of cookies. We had a lot of fun. So I think, yeah, check. All right. And then in terms of listening and role clarity, right? So when you're writing this kind of object-oriented code, it's because it's so modular, I don't have to go through this list and say, okay, I'm going to write the bakery, and then I'm going to write the baker, and then I'm going to write the customer. I can delegate those tasks to other people, right? I can say, all right, I'm in charge of the bakery. I'm going to design the best bakery this city has ever seen. I am going to say to whomever my teammate is, could you design a customer for me? If my bakery has so many cookies for sale, your customer should be able to provide some integer representing the number of cookies that they want to purchase. And so drawing these pictures, right? I mean, I'm a very visual person. I'm not an artist. I'm not good at drawing, but it helps me wrap my head around the project, right? So once we do this kind of thing, where I come up with this conceptual example of what it is that I want to do, I can break apart my project into these small individual things. And as long as there's, again, an agreed upon input-output format, I can work really easily with the rest of my teammates. And so I hope going forward in this Hack Week, you'll find this coding paradigm useful to you. But yeah, please feel free to reach out to me at any point this week if you have questions on how to do this well. It's a learning curve, and often it's more of an art than it is a science, right? There's more than one way to implement a function. So I'm definitely happy to offer guidance in that sense. That's it. Yeah, you're very welcome.
One or two questions before we break the topic.
I think there's a question over here. Yeah.
Can you quickly repeat what the double score underline means?
Yeah, so anytime you see a function that starts and ends with a double underscore, that is everything in Python is an object. And so we are secretly inheriting from the generic Python object. And so what those objects have is some kind of initialization. They also have some kind of string representation. All objects have some definition of value. So I can say greater than, less than, equal to. I'm sure there's other ones that aren't coming to mind right now, but by defining those default property or functions that all objects have, I'm overriding the default. And so Python, using those keywords or like that syntax, knows that to use the one that I've defined and not the default behind the scenes. Yeah.
So like length or Elliot, iter and next, have it iterated. You could do like an iter and have it iterate over your friend. It's like,
yeah, exactly. Yeah.
So I have a question about collaboration. Suppose like have several people working on one project, have multiple classes, and do you ever use like useful software to help you, like before really writing those classes? We can use some kind of software to build sit together and build a whole structure, like or a whole image about what will be the details of each classes. And because you have to clarify the connection between those classes, right? I'm wondering whether you think about that or just sit down and have a paper and
Yeah, absolutely. Formally, you can create what's called a UML diagram. So let's see if I can just find a quick. Okay, so I don't know, let's find a picture maybe. So these are excellent examples. Okay, there we go. So a UML diagram kind of looks like a flow chart. So it has each of these blocks is going to be a class, right? And so let's zoom in on this one. So this is our class name. These are going to be the attributes that our class has, and the next box is going to be the functions that class can perform. So this would be like bakery, some number of cookies, buy and sell cookies. And so if you want to be very formal about this, you can draw one of these diagrams, and then the arrows connecting those classes, depending on the arrowhead, these arrowheads all have different meanings. And like this is like, I could go on about this for like a week. we just don't have much time for it. So if you're more of like the advanced kind of software developer, this is definitely the kind of thing that you would want to do. But if you're just new to this, there's nothing wrong with drawing stick figures on a sheet of paper. Like that's what I still do. Yeah.
Can I also recommend the software that I used?
Oh, yeah.
There is a software called Power Designer.
Okay.
And you can build similar things like UML, and also you can do at the starting stage for the software engineering, discussing about different like other UML models. Yeah, from beginning to the end. So that
awesome.
software also works pretty well, and we use that during the classes for teaching also.
Very good. I'll have to look into that. Thank you.